We are trying to obtain the Cartesian and vector equation of a straight line. Suppose here a straight line which passes through a point A, which position vector of A is equal to vector B, and of any point lies on this line which we are trying to obtain. The equation is a point B which Cartesian coordinates are given and which position vector is R in general. And suppose it is a line which is parallel to a given vector Q. Here Q is given vector means Q is given, means coordinate A, B, C. This is actually called the direction ratios of a line. Now, we write the vector triangle, draw if this plus this vector is equal to clearly this. So actually this vector is the resultant of vector R and minus of P. This is actually lambda times of vector Q, because you know any parallel vector is written like this. Because the Q vector is parallel to this, so it is written like this, where lambda is any arbitrary constant, and suppose lambda is not equal to 0. Now actually if we write in this way, R is equal to actually vector P plus lambda times of vector Q. If we write this and this is actually a vector equation of a straight line. This is where R is any point on this line. Now changing its Cartesian coordinate for this, first write x minus of x1i and plus minus y1j. We write this and lambda times of here two vectors, one vector is this and another is this vector. So if vector are equals, then their component must be equal. So here we getting this and y1 lambda b and z minus z1 lambda of c. From here you x minus x1 y of a is equal to lambda y minus y1 by b equal to lambda z minus z1 by c equal to lambda, like this. Further, now if you write for this x minus x1 by a equal to y minus y1 by b and z minus z1 by c. Here a, b, c are called the direction ratios of line. This line. This is actually a Cartesian equation of a straight line, and that is the vector equation of line, either of this or this. You know that direction ratios are proportional to their direction cosines, where direction ratios never called direction cosine, but direction cosine may call direction ratios. Suppose L, M, N are the direction cosines of the same line L. So this will be a simple relation between direction ratios and their direction cosine. Suppose it is equal to k. Here k is not equal to 0. If you write A in terms of their direction cosine, it will be written this, and B will written this, and this 3 will be written like this. If we replacing these direction ratios here, here and here, you may this is actually x1 by L equal to y1 by y minus y1 by m equal to z minus z1 by n. Here is the term k is not present because we multiply this by k, also it is removing from here. Here L, M, N are the direction cosine. Here x minus x1 by L, y minus y1 by m equal to, all are equal, z minus z1 by n. So this is another form of, this is also called a Cartesian equation, where here represent Lmn is a direction cosine, but here direction ratios. All are the same representation, equivalent. This is this and this are the equation of straight line. Now taking an example on this problem, and you try to understand. Here we are taking as example, actually we have to find the equation of a straight line which passes through this point and parallel to this line. In this question, it is behaving as our vector q. This is vector q. This is actually in place of vector q. We may write 2, minus 1 and minus 3. This vector is written like another way. And the point is vector p. Actually it is 5 minus 2, this way. This so you know the r is equal to the p lambda times of the q 3. This is a vector equation. You may also write like this way. It is actually a vector equation, means it is written like this. This is written like this. This is a vector equation. Actually, if you're changing the Cartesian equation, you must write xi yj zk and if we right side, actually vector difference, not left and right side, then this will be I plus of 2 here j. Now j so and this is equal to 2 times lambda minus lambda j. This is, and if we here you see the two vectors are equal, so their components must be equal. So we if we are getting this x minus y is equal to 2 lambda y plus of lambda z minus 1 3 of lambda, and here we x minus y by 2 lambda y plus 2, minus, and so here we getting x 2 equal to y plus 2 and z. So this is Cartesian of a straight line. Now we are finding another equation. If we know the 2 points, so now we are trying to find the vector equation and Cartesian equation of a line if two given point P and Q are given. Suppose Y1, Z1 and Q, so given. Here is the case of the equation of line passing through 2 points. So in this case, suppose it is a position vector and it is the origin here. And taking another point on this. This is another point in general. Position vector is R. This is actually vector R minus of P, and it is parallel to the PQ. Here we write the equation R minus of vector P. You may also write R minus of Q. So here first writing this vector which is R and the vector minus of P, and same times of the PQ vector which is Q minus of P vector. This is our vector equation in this case. It is vector R and vector P is the lambda times A. Here it is same like the previous. This is given in terms of the given points here. These are the vector equation of a straight line when it passes through 2 given points. Now we changing it Cartesian. It's Cartesian form. So we may write this as this x minus x1 try y minus y1. This is actually, and here is nothing but the lambda times of x2 minus x1i, lambda times of y2 minus y1j, and the lambda times of z2 minus z1 of in vector k. Similarly, we equate here this as like this x minus x1 by x2 minus x1 and y2 minus y1. Equating this x minus x1 is equal to lambda x2 minus of x1 and y minus y1 is lambda times of y2 minus y1 and z minus z1 is lambda times of z2 minus z1. So if we can calculate as previous, we getting an expression x minus x1 by of x2 minus of x1, y minus y1 by y2 minus of y1 and z minus z1 z2 minus of z1. It is further equal to lambda, generally not urgent. Here this term are called the direction cosine. You may also write x minus x1, x1 minus of x2, y minus 1 y1 minus of y2 and z minus z1 by 1 minus of z2. This may be a Cartesian form. This is called the equation of straight line in 3 dimensions. It is same if it is the same equation as you written in 2-dimensional. If you write this equation, this is also applicable in 2 dimensions. If putting the z coordinate 0, suppose we are writing the equation of straight line in xy plane. So in the xy plane, z coordinate must be equal to 0. Student, be careful. It may or may not be 0. Not putting here 0. We must putting z 0 for any point. This is the z coordinate of any point in any plane. And suppose the plane is xy. So this is equal to 0 always for the xy plane, and it converted in the constant same ratio, and it converted like this: y minus y1 y1 minus y2 by x1 minus x2 and x minus of x1, like this. For clarity, we taking some example just for you. Suppose we have to find the equation of straight line which is passing through this point, two points like this, and 2 point this. These are the points on which a line is passes through, and we have to find the vector and the Cartesian equation on this. Here suppose this is treated as p, vector p, and this is q, and if you write in here, this is the equation. This is vector p 3, and this is q. So here lambda is p minus q. P minus q or q minus p, either may you use. So here q minus p, so q minus p is nothing, this minus this. Q minus p means q minus p when this minus this, because the pq vector goes on this. So you must you observe x2 minus x1 is present here. So similarly y2 minus. So you may write like this. This means minus of 2, comma this means minus of 5, and this minus this means 13. I suppose it is right. So yes, this is 2, and this is minus 2. Okay, yes, this is vector q. It is vector q. It's vector q, and then sorry, it is p minus q. It is p minus q. You may write p minus q. Sorry, here it is p minus q. Now, if you're changing this Cartesian, so you must written x3 minus 2 y minus minus 5 and equal to z minus 7 means this by 13. This is a Cartesian form of the equation. Suppose it is writing right, x minus of x1 like this here, x1 y minus y1. Just, I hope you understand. Now, actually taking here very simple examples. but these examples are basic for clearing the concept of writing the vector and Cartesian equation. And in next lecture we are discussing on the equation of plane and some another examples, mixed examples like plane and the line. And so thank you. For more clarity, you see the lecture order and you must satisfy. Thank you.